So one of the things that we think about, particularly when looking at nuclear energy, but really just any type of radioactive equation. So when we're thinking about these reactions that are happening, they fall into two main categories. And those categories are fusion and fission. And what happens during these reactions is just like what it sounds. So in a fusion reaction, you're going to have two atoms coming together, and their nuclei are basically just going to stick together to make a bigger atom. So two small atoms, specifically the nucleus, coming together to make one atom. And so we're looking specifically at what's going on with the nuclei in this reaction. So in a fusion reaction, they're going to come together and they're going to stick together. They're going to make a bigger atom. Fusion reactions typically happen with small atoms. Okay, so the hydrogens, heliums, those types of atoms, those are the ones that are going to go through fusion. They're going to stick together. Fusion does give off energy, surprisingly, and it actually gives off a lot of energy. So our fusion reactions are high in energy. An example of a fusion reaction would be a hydrogen atom with a mass of 1, say with a hydrogen atom with a mass of 2, and then that would produce a helium atom with a mass of 3. Okay, so we see two things coming together to form one. So that gives us a fusion reaction. A fission reaction is exactly the opposite. So it's one larger atom breaking apart into two smaller atoms. So two large, nope, not two, sorry, one large atom breaking into two smaller atoms. So again, this is a reaction that opposite of fusions, whereas fusion happens with smaller atoms, fission is going to happen with our bigger atoms. So fission is going to happen with uranium, plutonium, thorium. Our atoms with high atomic numbers are atoms with large masses. And so our fission reaction would look like the opposite of our fusion reaction. So let's say we have uranium-235. Uranium's atomic number is 92. And let's say it breaks apart into, I'm making this one up off the top of my head, let's say calcium, which has an atomic number of 20 and a mass of 42, which means that the other product would be, it would have an atomic number of 72, it would have a mass of, let's see if I can do math in my head, that would be a 3, 235 minus 42 would get me 193, I believe. Yes. And then whatever 72 is, let me go grab my periodic table. So on my periodic table, 72 is hafnium. I don't even know if this is actually a real fission reaction, but it gets the idea across. So it's one large atom breaking apart into two smaller ones. So again, law of conservation of mass has to apply. We're not gaining or losing any of our particles. They're just either coming together or breaking apart. So you might be wondering what's the difference between fission, two things coming apart like this, and the decay that we've already talked about. So when we talk about radioactive decay, that's when an unstable isotope naturally comes apart so that it forms two more stable particles. Whereas fission is more frequently thought of as an active, intentional breaking apart of an atom to get energy out. So both fusion and fission release energy. And so fission is more of the purposeful intentional breaking apart of an atom into the two smaller to get energy out. Whereas radioactive decay is viewed more as the naturally occurring process, where an unstable particle will break down into two more stable particles. So these are the two main categories that our radioactive reactions fall into, these two categories.